Hello everyone, welcome to my channel Cloud and Data with Kaushik. So today we are going to carry forward the previous session, right? So our ultimate goal is that we have to reduce the time that cars spend on the test bench, and this is the problem statement. So we have covered lots of things with the previous two videos. Now I'm going to continue from there, right? So without any delay, let's get started. So we can go over there, and from we have covered these things, the PCFR on the normal problem statement for the understanding purpose, right? I am not going to use this PCA in my data set, right? I am not going to use these things. Now I will do this. So you can say we have completed in the previous session the PCA on the iris dataset, right? That concept we have covered in the previous session. So you can see the code we already discussed, and the what is the definition of PCA, why I'm going to use that. So everything is discussed. Now what I'm writing, take one cell and you have to add your apply PCA or principal component analysis in your data set, in your data set, right? Data set. Go to the coding, and here we have to do this thing. So first we have to import. So I already imported these PCA libraries from the sklearn, right? You can see PCA is already imported. So this is the call from sklearn.decomposition, and you have to import your PCA. So let's do one thing. I have to copy, and here I have to reuse that. So enter code. Why I'm going to add this thing again? For entire block will be there. So you need to go and scroll up, because here I have to change something after this line. So that is the reason I have to add this input comment. But it is there, not for the one block you will be getting. No? So I'm writing the comment. So I twice the import is used because enter block from the actual dataset will be in same block. So we have to import the PCA and we have to set. So PCA is equal to PCA underscore in components is equal to point. So you can say linear dimension reduction using singular value decomposition, right? So it uses LAPAC implementation of the full SVD of randomized truncated SVD by the method of Halco ETL 2009. So that all definition you can get from there. So now I'm going to add in component, and the value will be 95, right? So you have to initialize your PCA. You have to initialize your PCA, right? And you have to fit PCA.fit, and your train data feature is ready. You have to fit on the train data underscore feature and train data underscore target. Now, is that clear, right? Why I'm going to do this thing? Because understanding is very important, right? So, if you have any questions, so please let me know. Then I'll proceed this part. So first we have to import our libraries, right? The PCA, any name you can take, okay? So you have to import these things. So I already used this import command in the previous in that earlier cell, right? But now again I'm going to do these things only because you can understand. So same block will be there, okay? So you don't need to confused over these things. Now question is that what is n component? Okay, let's discuss these things. N component parts, so you can understood. I'm writing in PCA. N components, you can say it's a number of principal components retention or extracted from the original data set. Okay, so these components you can say is a linear combination of your original variables and are ordered by the amount of variable they explain. So choosing the number of components in depends on the desired level of data compression or the amount of variance you are aim to retain. So I'm writing just only one line. So in components in PCA, choosing the number of, it's a number of components, right? What is in components differs in PCA? Good question. So in PCA, choosing the number of components in depends on the desired level of data. Desired level of data compressions, you can say, or you can say the amount of variance one aims to return. So one example we can say, so typically one examines the cumulative, I hope you can know the cumulative variance, and selects a number of components that can capture a sufficiently high percentage of the total variance while you can say reducing dimensionality. Okay, so in components, it's a number of components depends on the desired level, or you want to try to retain for the compression part, right? So that is the reason in components. So here you can say we can initialize the PCA and now and now we can fit it with my train data feature and train data target. Yeah, yes. So now you have to execute this cell. Okay. I hope I added all the comments over there and I have discussed these things. So let's try to run. And your execution is working there. So you can see the PCA components that will be created, right? That model means you can say it's not a model. So it's a this component modularized we have covered, right? So you have to initialize the PCA and you have to feed the data with the PCA dot feed. Here I am going to take the PCA dot feed. Okay. Now what I will do, I will take that feed transformation method over here. So that will be, we have to take feed transformation method here. What I'm going to do, PCA dot feed underscore transform, that you can see, and you have to add train underscore data underscore feature. Okay, and you have to assign one variable like train underscore data underscore feature underscore this file. So you have to add these things. Before going to that, I wanted to see if we have to print the PCA. So print your PCA. Yes, so it's a n component 0.95, right? And type print type you can write PCA. Yes, so you can see it's a class library of scalar.decomposition.pca. So everything is fine. So now we have to execute this cell train data and we have to feed transform this train data feature, right? Now we can print that. Step by step, we can understand the process. Okay. So I do not do each and everything at a one cell. So I'm not going to do everything in one cell. I have to break it in step by step so you can understand. Now we can print the PCA dot feed transform method. So you have done already this part and now you have to print. Just so feed data transformation method is already applied this PCA feed transform, right? Oh, also we can see the type print. You can also take its type, because type we have to always understood. And now so it's a numpy array, right? That also been provided. So you already have got the PCA feed transform method, right? You already did this. Now our question is that we have to last in the problem statement one more question they have asked, like we have to predict the testing part, right? Test DF, we have already done the test DF. So let's check with the help of XGBOOST. XGBOOST model. Okay, so test underscore TF we have, and we have to test TF is not there. 1 minute. So I just data set train. Oh, 1 minute. I'm just going to write. Next, take one cell, and here you have to write predict with XGBoost. Okay, we have to predict this thing with the XGBoost.